Hello again. This is the Pencrest High School AP Physics C video series, video 2D, static and kinetic friction. So some of this material is going to seem like a review. Certainly the formula is going to be familiar. Magnitude of the friction force. FF is less than or equal to mu times Fn. On your formula sheet, it's shown with absolute value symbols. We note that this is not a vector equation. The directions are not the same. We already know the directions of Fn and Ff. Fn is perpendicular to the surface and outward. Ff opposes motion or an impending motion, so this formula only applies to the magnitudes. The mu, of course, is the coefficient of friction. We're familiar with that already. Mu of 0 would indicate a frictionless surface, and a mu of 1 would indicate a surface that's very rough. Usually we're dealing with coefficients of friction that are in between 0 and 1. We want to take a look at that formula once again. The less than or equal to sign requires a little bit of explanation. The mu times Fn term would be considered the maximum friction force that is available on the surface. It's possible for the magnitude of the friction force to be less than the maximum, particularly if the object is not moving or not moving yet. So we want to make a distinction this year to a much greater extent than we did before between what's called static and kinetic friction. Static friction is the friction force that's generated between surfaces that are not moving relative to each other, at least not yet. Kinetic friction is the friction force that is generated between surfaces that are already moving relative to each other. We're going to find that the static friction force is typically greater than the kinetic friction force. And a way to remember that is that it is harder to get something moving than it is to keep something moving once it's already moving. Quantitatively, the coefficient of static friction is typically greater than the coefficient of kinetic friction. What we'll see is that when we make a distinction between the two, static coefficient of friction is labeled mu sub s. Kinetic coefficient of friction is labeled mu sub k. So when we look at an object that is not moving, being held stationary, we find that the friction force is less than or equal to mu static times Fn. So we'll talk about when the friction force can be less than the maximum, less than mu static times Fn. Once the object is moving, then we can say that the magnitude of the friction force is equal to mu k times Fn. So once the object is moving, we transition into kinetic friction, which once again tends to be a little bit less than static friction. So typically what we need to do is figure out if the object is moving at all in order to know which coefficient of friction to use in the event that you are provided both of them. So the way we do that is to write a standard force equation. So a applied force minus friction force, that sort of thing. And we set the force equation equal to 0, and we use the maximum value of the static friction force, so mu s times Fn, and we see what kind of result we get. When we set the force equation equal to 0, what we're saying is that the applied force is just enough to get the object to exceed the maximum static friction force and get it moving. So we know there's going to be an MA term, but we assume that it's just barely enough to get the object to move. Once you determine the force necessary to get it moving, or the force that's just enough to get it moving, you would then use the same force equation, but then the friction force becomes kinetic friction because the object is now moving. Okay? So the trick is writing your force equation and setting it equal to 0, setting the friction force to the maximum, and effectively seeing what you get. Okay? So we're going to see some examples of that, particularly in the daily and on this weekly WebAssign. You will also be dealing with objects that are on ramps. Once again, we use the maximum static friction force to oppose the impending motion. With an object on a ramp, typically that would be down the ramp, so the friction would point up. But there are other examples. So we'll see several. In the meantime, the daily is going to address most of these types of situations in terms of getting an object moving, what's the minimum force required to get it to move, and what's the resulting friction force, and so on. So we will see that in today's daily. And that's it for static and kinetic friction. We're also going to look at friction as a positive force, which will be a new thing. So until next time, enjoy. I'll see you again soon.